Okay, so in this exercise we're primarily going to be looking at when you do a minus b formula and you end up with a square root of, let's say, something like minus 15 plus 8i. How do you deal with that sort of part in a minus b formula? So what we're going to do is the questions that come before that. So an example would be if I wanted to solve what is the square root of minus 15 plus 8i in the form a plus bi. What I can say is a plus bi equals minus 15 plus 8i. I can then square both sides and I can get a plus bi squared equals minus 15 plus 8i. And then I end up with basically what is question number 1. Okay, so what I'm going to do is I'm going to square out both sides of question number 1. So I'm going to get a plus bi and then a plus bi. Squared out, and I'm going to get a squared, then I'm going to get a abi plus another abi. So abi, and then it's going to be bi by bi, which is b squared I squared, which is minus b squared. Okay, and then when I do this, I'm going to get a squared minus b squared, and then plus 2abi. Now what you can see is there's a distinct real part and a distinct imaginary part. That's the real part and that's the imaginary part. That's going to be equal to minus 15 plus 8i. So we have an equation here. So we can have a squared minus b squared equals 8i, or equals minus 15. We have 2ab equals 8. Okay, so what we can learn from this is that if we divide 2a into that, we can get that b equals 8 over 2a, or simply 4 over a. You can insert this in this equation here, so what we're going to get is a squared minus 4 over a 2b squared equals minus 15. Square this out, and we get a squared minus 16 over a squared equals minus 15. And then we're going to put everything over a squared, so we're going to get another a squared here, a squared, and then a squared on the bottom, a squared on the top. Remember, we're not changing, the a squared is cancelled, so we're going to have a to the power of 4. And then we're going to have minus 16 equals minus 15a squared. Bring the a squared over to the right hand side. We have a4 minus 15a squared, plus 15a squared minus 16 equals 0. Now, what we got to remember is ab is an element R. ab are real numbers. Real numbers, okay? So in this technique we're looking for real numbers. Now what I can say is let x equal a squared. Therefore a to the power of 4 is a squared 2b squared, which is x squared. In effect, I've changed this into a quadratic equation in terms of x. Then what I'm going to get here is x plus 16, x minus 1 equals 0. Then we're going to get x equals minus 16, or x equals 1. Now x can't be equal to minus 16. X can't be equal to minus 16 because that would imply that a squared equals to minus 16, and as we already know, it has to be a real number. So a squared equals 1. So this means a can be equal to plus or minus 1. Now a being equal to plus or minus 1, that affects the b values. So now to figure out what b is, okay, so b is 4 over a, so when a equals 1, b equals 4 over 1, which is 4. When a equals minus 1, b equals minus 4. So there's two solutions. Because it's a plus bi, it's going to be 1 plus 4i and minus 1 minus 4i. Okay, so that's simply the way these ones are done. Now, if I was to do question 8 on the same way, what I would say is that I'd set up the same way. I would say that the square root of a plus bi equals the square root of minus 9 minus 40i. I'd square both sides, then I get a plus bi squared equals minus 9 minus 40i. And then I'd do the exact same technique as last time. I'd square it out, and upon squaring it out, what happened is I'd have what's it going to be, minus 9 here, minus 40i here, and then we have an equation of a squared minus b squared equals minus 9, and 2ab equals minus 40. Like last time, b is going to equal minus 40 over 2a, which is minus 20 over a, and then we're going to figure out what a is. So then we can put it in and we get a squared minus 20 over a 2b squared equals minus 9. We're going to get a squared, that's going to be 400 over a squared, which is going to be still minus 400 over a squared equals minus 9. I'm going to put them all over a squareds now. Okay, and then, oh, sorry, that's not right. Okay, so it's a squared over a squared. Then the a squareds on the bottom cancel. What we're going to have is we're going to have a to the power 4 plus 9 a to the power 2 minus 400. Okay, and that is going to equal 0. Now I'm going to have to write down the factors of 400. So I'm going to start off with 40 and 10. That doesn't necessarily work, so I'm going to go 40 divided by 20. Oh, sorry. 400 divided by 15 maybe. So still on the factors of 400, and 400 is also 25 multiplied by 16. We can see that the gap is a 9. Now we're going to change this, we're going to let x equal a squared. So it's like last time, we're going to get x squared plus 9x minus 400 equals 0. And then what we're going to get is x plus 25 x minus 16 equals 0. So we're going to get x equals minus 25. That can't happen because we can't have a squared equals minus 25. It has to be a real number this time around. And now we're going to have x equals 16, which means a squared equals 16, which a means a is plus or minus 4. Now that we figured out that a is plus or minus 4, we go back up here and we know that if a equals 4, then b is going to be minus 5. Or if a equals minus 4, that means that 20 divided by minus 4, b is going to equal to 5. So the two complex numbers we're going to be talking about here is going to be 4 minus 5i and 4 plus 5i. Okay, moving on to the next part. We're now going to do question 9. So we've done 1, 8 and 9. So 1, 8 and 9. So in question 9, looking at root 2i. Okay, so we're going to set up like last time. So we're going to put 0 plus 2i here. So the exact same scaffold as last time, 0 minus 2i. And then we're going to get 0 minus 2i. And then we're going to get a squared plus b squared equals 0. And the other one's going to be minus 2i. So we're going to have a squared minus b squared equals 0. And then what we're also going to have is that 2ab equals minus 2. b therefore equals minus 2 over 2a, which is minus 1 over a. Substitute it in, get a squared minus 1 over a, just 1 over a 2b squared, equals 0. Square root of 1 over a squared is going to be a squared minus 1 over a squared, and that equals 0. And then we're going to put in the a squared in the bottom here. Then we're going to have a to the power 4 minus 1 equals 0. And then we're going to change that, let x squared be equal to let x be equal to a squared. Therefore x squared equals a to the power of 4. So x squared minus 1 equals 0. So what we're going to have here is x squared equals 1. So x equals plus 1 or x equals minus 1. Can't be minus 1 because a squared can't equal minus 1 because it has to be a real number. Therefore a squared equals 1. A is equal to 1 or minus 1. So now that we know that a is 1 or minus 1, we now have to figure out what b is. B is minus 1 over a, so minus 1 over 1 gives me minus 1. And when a is minus 1, b equals plus 1. So the two answers are 1 minus 1i or minus 1 plus 1i. Okie dokes. Okay. So find two complex numbers p plus qi for which p plus qi squared equals minus 24 plus 10i. Okay, so this is very much like the last question. So what we're going to do is we're just going to square out p plus qi into p plus qi, and you'll see it's the same system. You're going to end up with p squared plus 2pqi. And then it's going to be q squared I squared, and that sums up to minus q squared, and that equals minus 24 plus 10i. Then you just got to run through your system where p squared minus q squared is the real part, and that equals minus 24, and 2pq equals 10. Therefore q equals 5 over p. Substitute the 5 over p into the quadratic equation, so you get p squared minus 5 over p squared equals minus 24. And then you're going to get p squared minus 25 over p squared equals minus 24. And then we're going to get p squared in here, p squared and another p squared. The p squareds on the bottom cancel. And we end up with p to the power 4 minus, bring over to 24p squared, so it's going to be plus 24p squared minus 25 equals 0. I'm now going to say that p squared equals x, therefore p to the power 4 equals x squared. So it's going to be x squared plus 24x minus 25 equals 0. And then what we're going to do after that is a equals 1, b equals 24, c equals minus 25. Oh sorry, not even that, that's a minus b formula, we don't need that. We just do a regular old quadratic like x plus 25 and then x minus 1 equals 0. X cannot be equal to minus 25 because that means that a squared is equal to minus 25 and these numbers have to be real. So therefore x equals 1, a squared equals 1, a therefore is plus or minus 1. Go back to the top. Sorry, not a, it's it's p. P is equal to plus or minus 1. So when p equals 1, q equals 5. When p equals minus 1, q equals minus 5. So what we have here is 1 plus 5i or minus 1 minus 5i. Notice that they're the plus or minus version of each other. Okay, so next thing on question 11. Hence determine the two roots of the equation z squared minus 3 times 1 plus I times z plus 2 times 3 plus I. Okay, so that next part of the question, the hence is actually a minus b formula. Okay, so a equals 1, b equals it's going to be minus 3 minus 3i, so minus 3 minus 3i. Therefore minus b is 3 plus 3i, and then c is going to be 6 plus 2i. Now that that's done, what we're going to do next is 3 plus 3i plus or minus the square root of b squared. Now b squared is going to be minus 3 minus 3i minus 3 minus 3i, and that is going to get me 9 plus 9i plus another 9i plus 9i squared. The 9i squared changes to minus 9, cancels with that, so it's going to be 18i. Then it's going to be minus 4ac, so minus 4 times a is 1, and then c is 6 plus 2i, so that's going to be minus 24 minus 8i all over 2. Now here's where the first 10 questions start to come in useful. So we have 3 plus 3i here, and then we have plus or minus the square root of, what is in here? It's going to be minus 24 plus 10i. And what did we have in the first question? In the first question we had minus 24 plus 10i. Okay, and what we learned is that when you square root both sides, what you can then say is that p plus qi equals the square root of minus 24 plus 10i. So our answer from earlier, these two answers here, are what we need for this part here. Now we only need one of them because they're both the plus or minus version of each other. Okay, so we can do is 3 plus 3i plus or minus, I usually take the positive 1 plus 5i all over 2. Now we're going to get our results here, so it's going to be 3 plus 3i plus 1 plus 5i all over 2, which is going to be 4 and 8. 4 plus 8i over 2, and that in turn is going to be 2 plus 4i. That's one answer. Then the second answer is the negative version, where we have 3 plus 3i minus 1 minus 5i. Same thing as using the second version here, and what we get is 2 minus 2i all over 2 is 1 minus I. So there's our two answers there for this question 13. Oh, sorry, question 11. Now we're on to question 13. A very similar question. So in question 13, we square this out like we have done the last couple of times, and we get a squared plus 2abi plus b, minus b squared, because it's plus b squared I squared, which is minus b squared. And then we get that must be equal to 3 plus 4i. Then once again we're going to get a squared minus b squared equals 3, and 2ab equals 4. B therefore equals 4 over 2a, which is the same thing as 2 over a. Input that into the quadratic and we get a squared minus 2 over a to be squared is going to be 4 over a squared equals 3. Put them all over a squareds, and then what we get here is a to the power 4 minus 3a squared minus 4 equals 0. Let x be equal to a squared, such that x squared equals a to the 4. Then we get x squared minus 3x minus 4 equals 0. And then what we should get here is solve this, and we get x minus 4 x plus 1 equals 0. And then we're going to get x equals 4 or x equals minus 1. It can't be x equals minus 1 because a squared cannot equal minus 1. As in read in the description, we need a and b to be normal numbers. So what we get here is we're going to get a squared equals 4. Therefore a is equal to plus or minus 2. Now that we know that a equals plus or minus 2, so we'll have two different complex numbers, a equals 2, a equals minus 2. Therefore b is going to be 2 divided by 2, which is 1, or 2 divided by minus 2, which is minus 1. Our two complex numbers are 2 plus 1i, or 2 minus, or say minus 2 minus 1i. Okay. Now that that's done, what's going to happen next is we're going to, hence using this answer here, show that one of the roots of the equation z squared plus 2 minus I minus 2i is a real number and the other is a complex number. The roots. So roots means solve the equation. It's a quadratic equation because it has a z squared, is z, and just a number without a z at the end. So what we're going to do is we're going to say that a equals 1, b equals 2 minus I, c equals minus 2i, and then we're going to jump into this question here. Okay, so minus b plus or minus the square root of b squared minus 4ac all over 2a. So minus b is minus 2 plus I. So minus 2 plus I plus or minus the square root of b squared. B squared is 2 minus I, multiplied by 2 minus I. And that's going to get me 4 minus 4i plus I squared. Plus I squared is minus 1. So it's going to be 3 minus 4i. So 3 minus 4i in there. Now I have to do the minus 4ac part. Minus 4 times a times c. And that will get me plus 8i. And then minus 4i plus 8i is going to be plus 4i. All over 2a. And 2a is going to be 2 times 1. Now, what we solved in the first part of the question was, what is the square root of 3 plus 4i? We know that a plus bi, if we square root both sides, has to be equal to 3 plus 4i. We can take the positive or the negative version. We might as well take the positive version, 2 plus 1i. So this here, I can replace it with 2 minus 1i, minus 2 minus 1i, or I can replace it with 2 plus I. So I'm going to replace with 2 plus I. So 2 plus I plus or minus 2 plus 1i all over 2. Now the first answer is going to be minus 2 plus I plus 2 plus I all over 2. And we can see that the 2's cancel. It's going to be 2i over 2, which is I. It's purely imaginary as per description. Other is a complex number. It's a complex number. Now what about the real number? We'll try this here. So we're going to get minus 2 plus I. Take away the negative version, which is going to be minus 2 minus I all over 2. And we get minus 4. The i's cancel over 2, which is minus 2. And as per description, it's a purely real number, which is minus 2. Okay, so basically guys, all these questions seem to follow the same pattern. Okay, so what we'll try here is number 15. Find two complex numbers a plus bi such where a plus bi squared equals 15 plus 8i. Same deal as last time. We're going to have a squared minus b squared equals 15, and we're going to have 2ab equals 8. As per the last couple of questions, we're going to find out that b equals 4 over a. We're going to put that in. We're going to get a squared minus 16 over a squared equals 15. We're going to put them all over a squareds now. And then we're going to have a to the power of 4 minus 15 a squared minus 16 equals 0. Change x into a squared, or x squared equals a to the power of 4. So we're going to have x squared minus 15x minus 16 equals 0. We're going to have x minus 16, x plus 1 equals 0. It's going to be the x equals 16 answer we're after, so a squared equals 16. a is equal to plus or minus 4. Now that we put in the plus or minus 4, so a equals 4 or a equals minus 4, so we're going to find out is that b equals 1 or b can equal minus 1. Our two answers are going to be 4 plus 1i or minus 4 minus 1i. Once we've finished that part of the question, we're now going to solve this equation. To solve this equation, what we're going to do is try and solve this equation. So we can see I z squared, so that means that a equals I, b equals 2 minus 3i, minus b therefore equals minus 2 plus 3i, and c equals minus 5 plus 5i. Now that this is done, okay, so once again we're going to revert to the minus b formula. Before I do that, minus b plus or minus square root of b squared minus 4ac all over 2a. I want to find out what b squared is, so we're going to need this 4 plus I and minus 4 minus I, 1i in a minute. Just put it up here for storage and begin. Now b squared, 2 minus 3i, 2 minus 3i. When you square that out, you're going to get 4 minus 12i. You're going to get your plus 9i squared, which is minus 9. Then you're going to get minus 5 minus 12i. So minus b is minus 2 plus 3i, plus or minus the square root of, what was it, minus 5 minus 12i all over 2. 2 this time is 2i. And then what we're going to do next is we're going to do we're going to find out what minus 4ac is. So it's going to be minus 4i, because a is I, and then times c is minus 5 plus 5i. That's going to give me minus 20 plus 20i, and then minus 20i squared. And then minus 20i squared becomes minus 20. I'll say plus 20, so 20i plus 20. Plus 20 plus 20i. Now, if we've done this right, what's in the square root sign usually resembles part 1. So it's going to be 15 plus 8i. And let's long behold, 15 plus 8i. So, as we said before, if you square root both sides, you basically find out that a plus bi equals the square root of 15 plus 8i, which is either one of two of these answers here. So I'm going to take the plus version, which is 4 plus I. Doesn't matter which version I do take, because it's all plus or minus anyway. And this is going to be all over 2i. Now the 2i on the bottom extends the question a little bit, so it's going to be minus 2 plus 3i plus or minus, what's it going to be, 4 plus I all over 2i. And then what we get here is minus 2 plus 3i plus 4 plus I all over 2i, or minus 2 plus 3i minus 4 minus I all over 2i. And then what we get here is 2 plus 4i all over 2i. And then this one here is going to be 3i minus I is plus 2i, so it's going to be minus 6 plus 2i all over 2i. Now we can get rid of the 2's, we can divide everything by 2, so we get 1 plus 2i over I, and then minus 3 plus I over I. Now we're not allowed to have I on the bottom because the question specifically says in the form solve the equation. Okay, solve the equation usually means in the form a plus bi. Okay, so what we need to do here is multiply the top and bottom by the conjugate. The conjugate, if you think about it, is going to be 0 minus I, 0 minus I, 0 minus I, 0 minus I, and then multiply it out. We're going to get minus I plus minus 2I squared, minus 2 times minus 1 plus 2, all over minus I squared, and then it's going to be minus 3I minus I squared, all over minus I squared. Minus I squared is plus 1, so plus 1 on the bottom, plus 1 on the bottom. And we're going to get 2 minus I on top, and this one is going to be a plus 1. So 1 minus 3I and 2 minus I are my two answers. There you go. Okay. We might figure out what question 16 is before we leave. So question 16. Find two complex numbers x plus yi such that x plus yi squared equals 2 minus 2 root 3i. Okay, so let's figure out how to do number 16. So, number 16, we're going to have square out both of them, and we're going to get x squared plus 2xyi minus, it's going to be y squared, I squared, and then it's going to be minus y squared. And that equals 2 minus 2 root 3i. Just squared it out here basically. Then we're going to have x squared minus y squared, which is the real part, equals 2. Then we're going to have the imaginary part, 2xy equals minus 2 root 3. Okay, we're going to cancel the 2's, and we're going to get that y equals minus root 3 over x. On completion of that, we're then going to put them in here, so we're going to get x squared minus bracket. Now, when you square that out, y squared is going to be minus root 3 over x, multiply them, and you're just going to get 3 over x squared. So it's going to be minus 3 over x squared equals 2. Now put them all over x squared. And then we're going to get x to the power 4 minus 2x squared minus 3 equals 0. We're going to substitute in a new letter. We're going to let a be equal to x squared such that a squared equals x to the 4. So it's going to be a squared minus 2a minus 3 equals 0. A minus 3, a plus 1 equals 0. A equals 3, a equals minus 1. It can't be equal to minus 1 because it can't be a real number. Therefore x squared equals 3. X equals plus or minus root 3. Now that we figured out that x equals plus or minus root 3, we're going to have to figure out what y is. Okay, so y equals minus root 3 over x. So when x equals plus root 3, y equals minus 1. And when x equals minus root 3, y equals plus 1. So the two values are root 3 minus 1i, or minus root 3 plus 1i. And here's our two answers. Okay.